Right now, as you read this, there are millions of homeowners in the United Kingdom and across the United States paying hundreds of dollars every single month to heat rooms that a $3 terracotta pot and a single candle could heat for free, not partially, not uncomfortably, all night. And the most disturbing part is not that this solution works. The most disturbing part is how long the heating industry has known about it and how methodically, how deliberately they have made sure you never heard about it. The average American household spends over $2,000 a year on heating bills. In the UK, that number has surged past £1,500 annually, with energy companies posting record profits in the same fiscal years that ordinary families were choosing between heating and eating. And somewhere in that gap, between what you're paying and what you actually need to pay, sits a terracotta pot, a tea light candle, and a piece of physics so elegant it almost seems too simple to be real. By the end of this, you will know exactly how to build it, why it works at a level that most heating engineers will not openly acknowledge, and what mistake almost everyone makes the first time that causes the whole system to fail. Stay with me, because the next part changes everything. Here's what you're going to walk away knowing. You will understand the specific thermal mechanism that makes this setup work, and it is not what most people think it is. You will have the exact materials list, the precise configuration, and the one critical variable that determines whether this heats your room or barely warms your hands. You will see the side-by-side cost comparison that makes the numbers almost impossible to argue with. And I will also show you the one mistake that makes this method fail entirely. A mistake so common that it has convinced thousands of people this does not work when the truth is they simply built it wrong. Stay with me. The terracotta radiant heating system did not appear on the internet in the past decade. Its roots trace back to the basic principles of radiant heat storage documented as far back as the Roman Hippocaust, the underground heating systems that Romans used to heat their bathhouses and villas by capturing and radiating heat through stone and clay. Terracotta, fired clay, has one of the highest heat retention coefficients of any readily available material on Earth. Ancient engineers knew this. They built civilizations around it. The modern heating industry knows this too. And this is where it gets interesting. In the 1970s, during the first major oil crisis, a wave of low-cost radiant heating research swept through universities in Europe and North America. Studies were conducted on passive thermal mass systems, objects made of dense materials like clay, brick, and stone that absorbed heat slowly and released it over extended periods. The findings were remarkable. Small, targeted radiant heat sources using dense clay materials could maintain room comfort at a fraction of the energy cost of forced air systems. Several of those studies were quietly shelved, not because the findings were wrong, because the findings were inconvenient. The gas heating boom of the 1980s was accelerating. Central heating systems were becoming standard in new construction. The market had committed to an infrastructure of pipes, boilers, thermostats, and maintenance contracts. A solution that cost $3 and required no maintenance, no contract, and no professional installation was not a product anyone in that industry wanted consumers to know about. What they didn't want you to realize is that the physics of the system is the same physics that underlies radiant floor heating systems costing tens of thousands of dollars to install. The principle is identical. The scale is simply different. What I am about to show you is the part the industry spent decades making sure you would never find out. Because once you understand the mechanism, not just the steps, but the actual reason this works, you will look at your monthly energy bill differently. You will look at the heating industry differently. And you may never pay a contractor for a space heater recommendation again. The solution is a terracotta radiant heat amplifier. That is the technical description. In practice, it is a small terracotta pot, or a nested pair of terracotta pots, suspended over a tea light candle or a small cluster of candles on a fire-safe surface. And here is the reason it works. One clear, verifiable physical principle. A candle flame burning in open air releases the majority of its heat energy directly upward through convection, where it dissipates uselessly into the ceiling. That energy is lost. It heats nothing you care about. But when you place a dense terracotta vessel over that flame, with a calculated gap that allows the combustion process to continue, something entirely different happens. The clay absorbs the convective heat before it escapes. It stores it. And then, because terracotta has a significantly higher surface area relative to its mass compared to most materials, it re-radiates that stored heat outward in all directions as infrared radiation. Radiant heat, unlike convective heat, does not rise. It travels in straight lines from the surface of the object to whatever surface or body it encounters. It heats you directly, the way sunlight heats you, not the air between you and the source. This is the core physics. This is what makes this work. And this is why most people who try it wrong, using too large a pot, blocking airflow, or using the wrong candle type, report disappointing results. They are disrupting one of these three variables, and the system collapses. If you have been watching this channel and finding answers the industry does not want you to have, you already know what this community is about. If this is your first time here, consider joining the people who choose information over ignorance. Now let us build this properly. Step 1, your materials. You need 2 unglazed terracotta pots. The smaller pot should be approximately 4 inches in diameter, measured at the rim. The larger pot should be approximately 6 inches in diameter. These are standard nursery pot sizes available at any garden center, hardware store, or large format retailer for under $2 each combined. You need a metal bolt, approximately 3.5 inches long with 2 matching nuts and 4 or 5 washers. You need a fire-safe surface. A ceramic tile or a small metal tray works perfectly. And you need standard tea light candles, which are available in bulk for pennies each. Do not use scented candles. This is not about aesthetics. Scented candles contain additives that alter the combustion process, and in enclosed configurations can release compounds you do not want concentrated in a small space. Unscented tea lights only. Step 2. Assembly. Thread the bolt through the drainage hole of the smaller pot from the inside outward. Secure it with a washer and nut on the outside, then add 3 to 4 washers stacked along the bolt shaft. These create the critical air gap between the 2 pots. Thread the larger pot over the bolt from the outside, and secure the assembly with a final washer and nut. This bolt and washer system is the most important structural decision in this entire build. The washers create a small, consistent gap between the 2 nested pots. That gap is what allows air to circulate and heat to distribute evenly across both clay surfaces, rather than concentrating at a single point. Step 3. Placement. Set your fire-safe tile or metal tray on a stable, flat, non-flammable surface. Place 2 to 4 tea lights in the center of the tray. Not more than 4, and not touching each other. Lower your terracotta assembly over the candles, resting on the edges of the tray, or on small fire-safe supports that leave a 1 to 2 inch gap between the bottom rim of the outer pot and the surface below. This gap is not optional. It is the combustion airway. Block it, and the candles extinguish themselves within minutes from oxygen depletion. This is the single most common mistake people make, and it is why thousands of people have tried this, reported that it does not work, and given up. Without ever understanding, they simply sealed off the airway. Step 4. Allow 15 to 20 minutes for the terracotta to reach full thermal saturation. In the first few minutes, you will feel very little. This is not failure. Terracotta is absorbing heat. It is storing it. At full saturation, the outer surface of the larger pot will reach temperatures between 140 and 170 degrees Fahrenheit. Hot to the touch, but well below fire risk. From that point, it radiates heat steadily, continuously, for as long as the candles burn. A single tea light burns for approximately 4 hours. 4 tea lights, staggered in ignition timing, can sustain the system through an 8 to 10 hour overnight period. The fuel cost for a full night of radiant heat is between 30 and 60 cents. Before I wrap up, there's one more thing about this solution that almost nobody talks about. The directional nature of the radiant heat output means you can position this system strategically within a room to heat the specific zone where you sleep, sit, or work, without wasting any energy on the parts of the room you are not using. This is something even expensive electric space heaters cannot do efficiently. They heat air. Air moves. This heats surfaces and bodies directly in a cone of warmth that you control by rotating the assembly. In a bedroom, placing this at the foot of the bed creates a radiant warmth across the lower body that most people report feels more comfortable than forced air heat at any temperature. That is not anecdote. That is the difference between convective and radiant heat transfer applied to the specific geometry of how a human body loses heat during sleep. Now consider what you have been paying. The average American running a small electric space heater through the night, a 1500 watt unit running for 8 hours, consumes 12 kilowatt hours of electricity. At an average national rate of 16 cents per kilowatt hour, that is approximately $1.92 per night. Over a 6-month heating season, that is $346 for one room. One space heater. The terracotta system running 4 tea lights across 8 hours costs between 40 and 60 cents per night. Over the same 6-month season, that is between $72 and $108. The difference is over $200 per room. Per year. If you have 2 rooms, that is over $400. And that calculation does not include the cost of the original space heater itself, which can run from $30 to over $200, nor the maintenance, nor the safety risk. Electric space heaters are among the leading causes of residential fires in both the United States and the United Kingdom. Here is what the solution does not need. It does not need electricity. It does not need installation. It does not need a subscription, a maintenance contract, or a professional. It does not stop working during a power outage. In fact, the moment the grid goes down is precisely the moment this $3 system becomes the most valuable object in your home. Here is what most people who discover this system do not realize until it is pointed out to them. The same thermal mass principle that makes terracotta work for personal room heating is the foundation of a much larger, much more suppressed conversation about whole home passive heating. A conversation involving building materials, architectural decisions, and industry lobby groups that has been actively shaped for decades to keep homeowners dependent on centralized, metered energy systems. The terracotta radiant heater is not the end of this story. It is the entry point. What happens when you apply the same principle, dense materials, slow heat absorption, long-duration radiant release, to walls, floors, and window placement, is a subject that entire engineering departments have studied, and that the construction industry has had very specific financial reasons to ensure never became standard practice in residential building codes. That story is considerably larger, and it raises a question worth sitting with. If a $3 pot and a candle can demonstrably replace a $200 electric heater for overnight use, what else has the energy industry convinced you that you cannot live without?